In this video, I would like to present about the Taiwan Ministry of Education Artificial Intelligence Competition 2019, especially task 2. The task 2 is how we classify a paper into one or several categories. This competition held by the Ministry of Education. The task is about thesis paper classification, and the task is we predict the classification of thesis into the following categories. The categories can be one or several, like one paper could be a theoretical, or another paper could be a theoretical, engineering, empirical, and others. And from the competition itself, this is like a multi-level classification task. We get three data sets from the competition. The first one is task 2 transet, that consists of 7 features such as ID, title, abstract, author, categories, created date, and also the task 2 with 7,000 data. And then the second dataset is task 2 public test. It is for this is with this data is to for us to test our result in the system, and then we will get the score and also the leaderboard for this data. As we can see from right now, the latest leaderboard is 73%, and then the second one is the 72%, and until the fifth ranking 72%. And then from the training set data, actually there are metadata like ID, and then the title of the paper, and then the abstract of the paper, the authors, the category, and created date. And after that, you would like to know the distribution of the paper category. As we can see on the slide, that the most distribution fall into the engineering categories, and the least percentage of the distribution is the categories, the others categories, by the 4%. As we can see for the distribution percentage, that it is not equally in the distribution. And then we would like to use the title and also the abstract for the features. So the first thing first, that we would like to know what is the top word in the title text. As you can see on the slide, that from the picture shows that from 100 top words in the title text is like a stop words such as for, of, and, in, ad, with, and so on. Maybe like learning, networks, neural, deep is a non-stop word, but it's also good. And then this is the picture on the 100 top words in the abstract itself. So as you can see, the top 100 word in the abstract text is also the stop word. And if we combine the title text and also the abstract text, and we would like to compute what is 100 top words, it's also the stop words. So it means that if you would like to get the important word as a features, we must eliminate the stop words. The stop word is such as the, of, and, a, to, in, This is not have a meaning, a special meaning in the sentence. So actually we can eliminate the stop words. So for the training phase, there are several steps, such as the first step, I divided the task and choose. The first step is I choose the feature or feature selection. For the feature, I choose the title and also the abstract, and for the target or label, I choose the task too. And then from this text, I try to do the text cleaning and remove the English stop words, and then I feed to TF-IDF vectorizer and input to my machine learning algorithm. On the other side, on the right side, because this is the multi-level classifications, so I need to convert the task to text into the multi-level vector before input as a target or as a label in the machine learning algorithm. And then in this process, when I do the text, when I do the text cleaning and also the remove English stop words, I got the meaning words. As you can see on the slide, this picture describe 100 top words in the title and abstract text after the cleaning. As you can see, the data and also the model and learning network, paper network results show us a great or important word in our feature. So after I do the training. So after I did the training, I do I do testing phase. The testing phase is we choose the task to public test set with 2000 data. So from the 2000 data, I use the title and abstract text to fit from the TF-IDF vectorizers that we already uh, trained before in the training phase. So after that, I also input the TF-IDF vector into the trained machine learning in the training phase. So after I get the prediction, I input into the samples, and also I produce the three-brain submissions that consists of 40,000 rows, and then have the features. I have the column like IT, theoretical, engineering, empirical, and others. So after I submit, we get the score and also the ranking itself from the public leaderboard. As you can see on the pictures, after I submit the machine learning algorithms, I got the 64 F1 measures and got the ranking 55 and got ranking 55th. I I did several I did the experiment from several algorithms, and I got uh, high. I also tuned my hyperparameters, such as when I use the multinomial naive Bayes and using the maximal decrement frequency 0.8, I got 0.64. And when I use the nearest neighbor with the 4 nearest neighbor, I got only the lowest one, a half or 49%. And when I used SG extreme gradient boosting, I got 63%, like this one. For the next task or for the future work, I would like to employ the deep learning method like LSTM or LNN, and also I would like to use word embedding to improve my accuracy, F1 accuracy. Word to fact or word embedding is one of the uh, the method that we can use to convert from the text into the vector other than TF-IDF. Word to vector is like the word to fact from the Google, or the glove from the Stanford, and the other one like bird from the Google. Thank you very much for watching my video. See ya.